NASA snaps an image of a massive eruption from the sun, a solar flare, as solar activity warning is issued for our Earth. The largest solar prominence eruption from the sun ever, captured in a single image detected earlier this week by NASA satellites, as experts warn of an increase in solar activity. Solar prominences are large, typically looping structures of tangled magnetic fields that drag plasma up through the sun's atmosphere over timescales ranging from hours to months. They appear bright when seen set against a dark background of space, but they're actually relatively cool, reaching temperatures of only 4,700 to 49,700 degrees Celsius compared to the whopping 1 million degrees Celsius of the sun's outer atmosphere, or corona. And scientists from NASA and elsewhere, the ESA, still working to determine exactly how and why prominences form, and understanding which would help us better predict the release in the future. The recent record-breaking prominence appeared February 15, and according to the European Space Agency ESA, it extended millions of miles out into space. As space weather expert Dr. Tamitha Skov explained on Twitter, she said this week's solar prominence is another example of how the sun's activity is ramping up as we approach the maximum of the current solar cycle 25, since the records began in 1755. She said first we got an Earth-directed solar storm, knocking down a few Starlink satellites. Remember that happened on February 4th. And now a massive far-sighted eruption is raising eyebrows of the Parker Solar Probe Operations team. These events surely hit a solar cycle 25 ramping up. Dr. Skov says she was referring to a geomagnetic storm earlier in the month that wiped out the 40 satellites from the Elon Musk SpaceX constellation because they were so far down towards our Earth. And before that, also, we had a blackout in Russia from the solar storm. Now, the geomagnetic storm. Now, fortunately for us, data collected by ESA NASA Solar Orbiter spacecraft shows that the release of the solar material was not directed to our Earth, and in fact, it's traveling away from us in nearly the opposite direction, thank goodness. The ESA spokesperson said this event did not send a blast direct of deadly particles towards our Earth. However, they said it is an important reminder of the unpredictable nature of the sun and the importance of understanding and monitoring this behavior. Prominences are associated with two other phenomena that can have an impact on technology here on Earth: the solar flares and the coronal mass ejection, CMEs. The former involves the abrupt release of high-energy particles, the energy equivalent of setting off millions of 100 megaton hydrogen bombs at the same time, which have the potential to interfere with satellite communications. CMEs occur when a prominence, rather than falling back into the sun and being reabsorbed, breaks free. When this traveling mass of charged particles encounters the Earth, it can whip up a so-called geomagnetic storm, causing not only communications interference but also interference with navigation and even causing power grids to black out. In September of 1859, a CME caused a geomagnetic storm dubbed the Carrington event. And that caused compass needles to swing wide off their mark, auroras to appear on the equator, can you believe that, above Columbia, and wreaked havoc on the telegraph network. According to reports, the storm induced such currents in telegraph wires that pylons sparked, operators received shocks, and some lines were able to operate even when the power supply had been switched off. Now, while Earth's atmosphere protects life on its surface from radiation from such weather events, space weather, astronauts on future long-distance space missions will be much more exposed, meaning that their crafts will need to be appropriately shielded. Images of the recent prominence were captured by the so-called full sun imager sensor on the Solar Orbiter satellite. It's designed to look at the full solar disk even when the craft is making close passages of the sun. And according to the ESA, even spacecraft not specifically designed for solar observations felt the effect of this blast. The radiation monitor on ESA and Japan Aerospace Exploration Agency's joint BEPI Colombo mission, for example, detected a massive increase in electrons heavy ions and protons from the solar expulsion from its location near Mercury's orbit. Other space telescopes, like the Solar Heliospheric Observatory SOHO satellite, often witness solar activity like this, ESA experts explain, but such is typically observed either closer to our sun or through the obscuring lens of the so-called occulter, which is designed to allow detailed imaging of the corona by blocking out the glare of the sun's disk. Now, given this, the ESA said, the prominence observed by Solar Orbiter is the largest ever event of this kind to be captured in a single field of view together with the solar disk. And the feat, they said, opens up new possibilities to see how events like this connect to the solar disk for the first time. This is by Express UK Ian Randall. And concerning space weather, what they said, the geomagnetic storm watch, minor G1 class geomagnetic storms possible February 20th, when a co-rotating interaction region, CIR, is expected to hit Earth's magnetic field. CIRs are transition zones between slow and fast-moving solar wind streams. Solar wind plasma piles up in these regions, producing shock-like structures that can spark bright auroras. And according to space weather, G1 minor geomagnetic storm impacts that we will have. Power systems have weak power grid fluctuations can occur. Spacecraft operations, minor impact on satellite operations possible. Other systems, migratory animals are affected by this and at this and higher levels. Aurora, as commonly visible high latitudes, can be seen in Michigan and Maine. Now, concerning the CIR, the co-rotating interaction region, expecting to hit Earth. The previous section showing the fixed observer relatively close to solar equatorial plane will observe a successive fast and slow solar wind streams during much of the solar cycle. What interactions are there between the streams? Obviously, there must be interactions because plasma from the fast stream will catch up with and overtake plasma from the slow stream. And the formation of a compressed region in the rear of the slow stream, likely forming shock emanation from the compression. Most likely two, as discussed, and the rarefaction regions at the rear of the fast stream. Can you imagine? They'll be plowing into each other. Now, we're going to see I'll have another video about the comets plowing into the sun, and we have a video on that. But we have the aurora alerts, X-ray solar flares, B8, 6-hour maximum B8, February 18, 24-hour C1, February 17. So we're having solar flares coming in now. If you have a fluctuation in your electricity, you know that's probably why. If you have some kind of a headache or your head feels heavy, that could be also what's happening now. The next video will be on the two doomed comets plowing into the sun. And I'll leave links below for you for this on space weather. Please leave your comments. Thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.